So now let's look at computing some double integrals using polar coordinates. So let's look at the following example. Let's let R be the annular region lying between the two circles x squared plus y squared equals 1 and x squared plus y squared equals 5. Evaluate the integral over r x squared plus y dA. So the first thing we need to do is we need to write our region with polar coordinates. So convert our region here. I'm looking at a circle of radius 1 and then a circle of radius square root of 5. That's a little bit bigger than 2. And I'm looking at between those. So again, that's an annular region. So I can write this region R. R is between 1 and the square root of 5. And theta is between 0 and 2 pi. So I've written my region like that. And so now, don't forget, we're going to need to plug in place of x our cosine theta. So really, in ours, we have an x squared. So x squared would be that squared. And y will be r sine theta. So now, I'm going to change over my double integral over r. It'll become the integral from 0 to 2 pi and 1 to square root of 5. And x squared, we said is r squared cosine squared plus r sine theta. Because we're switching to polar, we get this extra r, dr d theta. So the first thing I'm going to do is I'm going to distribute this r right here out. So 0 to 2 pi. So this will be r cubed cosine squared plus r squared sine theta dr d theta. I'm first integrating with respect to r. So I'm going to get r to the 4th over 4 cosine squared theta plus r cubed over 3 sine theta. So here I'm going to get the integral from 0 to 2 pi. If I plug in square root of 25 to the 4th power, the square root of 5, when I put it to the 4th power, I'll get 25 over 4 cosine squared theta plus 5 square roots of 5 over 3 sine theta minus 1/4 cosine squared theta plus 1/3 sine theta. And then I guess I should have some parentheses here, d theta. So now we can combine some of these. So 0 to 2 pi, it'll be, if I subtract 25 over 4 minus 1 over 4, that's 24 over 4, which is 6. 6 cosine squared plus 5 square roots of 5 minus 1 over 3 sine theta. And now integrate with respect to theta. So you can integrate sine, but remember to integrate cosine squared because the power is even. You're going to have to use your double angle formulas. So this is 6 times 1/2 1 plus cosine of 2 theta. So if I simplify that first group right there, I'll get 3 plus 3 cosine 2 theta sine theta. Now integrate this, you'll get 3 theta. And you'll have to do a u sub for the second one, so it'll be 3 sine 2 theta over 2. And then the integral of sine is minus cosine. And then we just have to plug in our bounds now, top minus bottom. So you get 6 pi plus 3/2 sine of 4 pi minus 5 square roots of 5 minus 1 over 3 cosine of 2 pi minus, so you get 0 plus 3/2 sine of 0 minus 5 square roots of 5 minus 1 over 3 cosine of 0. So sine of 4 pi, that is 0. The same thing with sine of 0 is 0. Cosine of 2 pi is 1. And so is cosine of 0. So in the end, what am I going to get for this integral? I'm getting 6 pi. And then these two terms here and here have opposite sign because there's a minus out front. So they cancel. And it's just going to be 6 pi.